Attention now, B part 8 is miscellaneous tips, okay, on applied math and physics. This is miscellaneous tips, you see. Now, lecture 6, Cartesian product and tensor map. A Cartesian product is a fundamental set, theoretic construction, and it underlies how we define a tensor maps. Tensor maps are related to Cartesian product. Now, definition and simple example. Definition of Cartesian product. Given two sets, A and B, their Cartesian product is the set A times B, okay? This is equal, that's a set, okay, A and B, such that A belongs to A and B belongs to B. Just for you to understand clearly, I will give you a numerical example. Give, for instance, A, 1 and 2, B, 3, 4, 5. From the definition over here of Cartesian product, this. Now, for A is equal 1, which belongs to the set A, you see 1, 3, 1, 4, 1, 5. Likewise, for A is equal 2, which belongs to A, is 2, 3, 2, 4, and 2, 5. Now you collect, okay, all these possibilities, and then this leads to the full set, which is A times B. You see, this is a full set over here. I just copy from here to over here. So, attention. This important Cartesian product related to the tensor map. Slot structure. Tensor is a multilinear maps that take several vectors and covectors as input. You see, in general, you use a bilinear map, you see, then this is multilinear maps, okay, the tensor. Okay, so in this case, formally, an RS tensor is a multilinear map, capital T over here, you see, such that T is a map, okay? All this blue one here, they are the domain, okay, in which Tx of this domain. This leads to the codomain with the real number. By definition, okay, of tensor, this leads also to the real number. This I have R times, okay, and this S times. You see, these V stars, okay, they belong to the dual space, and V belongs to the vector space, you see. Now, so the Cartesian product provides the domain, the blue one, on which the tensor T acts to lead to the codomain, which is a green one, you see? Now, codomain is a real number R, by definition, okay? That's a map. We say that the tensor T is of type RS. R from in this case, okay, on the dual space, V star, and V asterisk, let's say, and S is from V, okay? Instead of star, let's use asterisk. So, number 1, 2, 3. Why lower and upper indices, okay? A covector alpha, okay? Covector alpha, it belongs, attention now, to dual space, okay? Alpha belongs to V asterisk, acts on a vector V, which belongs to the vector space. This by alpha, in this case, acts on V. This alpha J, attention now, you see, this characteristic here, okay, alpha J is called covariant because the lower index, okay? The basis is contravariant, but we call this alpha J EJ. And VI EI belongs to the vector space, okay? But the components here, they are called contravariant components, okay? And the bases are the covariant components. Contravariant will have upper indices. Covariant will have lower indices. So then let's act alpha j, ej, alpha I, vi, ej act on ei. Attention now, by definition, there is no question, okay? When you say by definition, you have to assume that is true, that is valid. So this EJ, by definition, is the chronic delta, delta ij. And the property of delta, the chronic delta, you know, when I is equal to j is 1. When I is different from j is 0. And also you see on the right hand side, all these are dummy indices, okay? So j dummy and I dummy. So this is a real number, okay? Dummy, okay, correspond to a real number, okay? Now this alpha I, in this case, vi, which belongs to the real number. And since, I repeat, Lj atom ei is by definition delta ij, okay? So this is known as a delta. Now it's important issue here just for you to understand that a tensor is a map, okay? And then we use the Cartesian product properties just to move to the definition of a tensor, which is a map. That's it. I'll give you next some numerical examples just for you. It's important here that R and S, okay? You look at here and R and S. You see R times, okay? You have R, in this case, V asterisk, S times S and V. This belong, attention, again, this belongs to the vector space and this belongs to the, in this case, on the dual space, okay? That's a mixed, you can mix that. You see some numerical example in the next lecture, okay?